let's see. So first of all, we need to guard this thing because it might be null because we're destroying it sometimes. If I remember right. Yeah, like right here we're setting it to null. Yeah, so to avoid a null pointer dereference, let's just guard it. Okay, now this thing. We have this buffer mapped. I don't know if that actually matters for releasing it, but we're gonna find out. Alright, install. Yeah, so let's just go up to here. So first of all, no errors, right? No errors. Now we close it. There we are. Okay, no errors so far. Seems to be fine. Yeah, I think we always pretty much had that. Okay, so it seems to be that we unless this is happening because it's mapped, I don't know, let's see. How do you unmap it again? Like that. Okay, so run it, close the window, then step over that. Okay, so, well, we still have these exceptions. I don't know, where are they? No, yeah, these are just here, but they're like always here? Yeah, probably always here, alright. Yeah, let's just unmap it, just in case, like, who knows with the graphics drivers. Alright, so that's clean up. Now, let's actually do something with the rectangles. So right now I'm just pushing them in, like here, just before unmapping and undrawing. So presumably, well, let's see, can we have persistent storage in this buffer? That we don't have to refresh every frame. Let's find out. Alright, so that's the mapped buffer, where it was mapped, you know, up here somewhere. Here, yeah. So that's the mapped buffer. Now, so if I push it here, I kind of want to modify it potentially, right? So when I remap it, okay. So first of all, can I do that? Or is that not allowed? Okay, that is not allowed. Attempting to unmap a resource that was not mapped. Well, that's not really what I expected to see there. Oh, because... okay. Devin... Man, look at the startup time. It's still going. Oh, we get syntax highlighting, okay. Are we done, Visual Studio? Are we done? I think we're done. Loading. Okay. Map cannot be called with map write access because the resource was created as a usage dynamic. Must either use what? Map discard or map write no override. Interesting. Well, map write no override sounds about right to me. Okay. Just okay. Map write no override. I guess. Okay, well I did something. Okay, and so if we go into the rects, right, mapped putter, can I oh, where is my watch window? Where is Windows? Oh my god. Autos, search depth 3. Yeah, like there it is. Watch 1. I just copied the. Okay, can I? No, I have to. Rects mapped lang. What? No, I want more than one of these. Like, what? Yeah. What is it? What is the? What is the instance? Is it like that? Like, what do you want? But can you expand this? No? No. This is, I'm not allowed to know what this is. I'm not allowed. I'm not. I guess we are gonna have to use 3 debuggers. I guess this is just how it's gonna have to be. Oh, maybe not actually. Maybe this is just as bad. Is it because it's like GPU memory, so like we're not allowed to look at. I mean, it knows what the type is, but like, what does this error message even mean? All I want to know is like if I can have persistent storage. That's all I want to know. It seems like I can, actually. And don't think these should change. Yeah, so the pointer doesn't change now. We can't examine what the contents of that buffer are because, like, well, how could you possibly examine memory? No one's ever done it. Okay, so now that I know that we can have persistent storage, let's see. Well, we could just go into that and manipulate it, presumably. Switch message. So that's the default. Case quit. Well, now this break breaks the... So that's the quit. So now we don't actually have to do this weird... Oh my god, weird trickery with the if statement. So we'll loop over all the messages, break main loop here. Default is translate dispatch. Should I just like one-line this? Because I don't really care, right? Okay, so now let's look at the actually interesting cases, right? So case WM mouse motion, so the mouse move, case WM key down. Yeah, I'm just gonna intercept these. No reason for us to pump that through the whole callback thing. Just intercept them. Well, I mean, the whole point was... Well, actually, hold on. Let's intercept... Well... So what I want to do is manipulate the rectangles based on keystrokes. And probably the easiest way to do that actually is not even this. Like, we can read these key down messages and keep track of key state, but I think it's gonna be easier to just create a key state. Get keyboard state p byte LP key state. Okay, so let's find out what this is. 256 byte array. Well, I mean, I guess you wait. Keyboard 256. Okay, Okay, so we just get keyboard state, and then for each virtual key, all those VK stuff, right? So like keyboard, if keyboard VK, well, I mean capital A, then let's just do something here, like go into that D3, D11, right, mapped pointer 0, position x minus equals 0.01, something like this. Are we gonna see anything? Oh my god, oh no. What just happened here? Why did Visual Studio start? What? Is it... does it know? Like, what's happening? Never mind, you know what, I was just gonna launch it here. Oh boy. Okay, I think by the sounds of it, something is still running there. No? Yes? Maybe? System interrupts. Why system interrupts? Let's just exit Visual Studio. CodeLLDB. Okay, well, alright. CodeLLDB is gonna, yeah, the debug adapter has terminated. Yeah, that's good. That's good. Okay, so what does keyboard state give us again? Current state. Yeah, so so that should be like interesting. Okay, some reason it just never stops. Does this not work the way I think it works? Like, what? I mean, we also call get key state. this just always returns true? Because it was pressed once? Why would that work like that? Why, what? Retrieve the status with the keys up, down, toggled. Oh, it's a short. Oh. Oh, so you actually need to like interpret this. Okay, this is not just a simple 0, 1. If the high order bit is 1, the key is down, otherwise it is up. If the low order bit is 1, the key is toggled. A key such as caps lock is toggled or is turned on. So, alright, let's actually see what that is in here. Just a short. Well, I'm going to add. Zero. Well, it's 0 now, to be sure. Interesting how you can't really set a breakpoint in. High order bit is 1, the key is down. Low order bit is 1. The key is toggled. Well, I'm seeing more than 2 bits equal to 1 here. So what's that all about? So like high order bit, like are they referring to this? I mean, I guess they're only referring to this lower byte, and this just doesn't matter. So like, well, since it's 1 shifted up by 7, I guess. So that's the high order. Well, I mean, so if that's supposed to signify that it's down, then no, it does. Okay. So the low order only really makes sense for things that get toggled. So I'm guessing get keyboard state. Well, does it return just a bunch of those? Does it work the same for get keyboard state, or? Yeah, there it is. Yeah, you're supposed to check the high order bit. And all of these APIs, they're like puzzles. Like, why? Why is it like this? Down mask is that. Okay, so we can move it around. I mean, I suppose there is no real, well, I mean, we can move up and down sometimes in the game. But the point of this exercise, though, was to see, to verify that we can have persistent storage be just sitting in that map buffer. So unless there is a reason not to do that, I'm just gonna keep it in there. Okay, well, what else do you want to do? Well, probably, like, changing the rectangles, like, that's not really what we want, right? We want to move the player around, presumably. So one of those rectangles is a player, like the first one. And so that needs to be represented somehow. And also, we need a proper texture, and not just these 4 pixels. And also, we need a coordinate system, because right now everything's being moved around in just clip space, directly in clip space, which is not what we want. So let's, I guess, well, also, this scale thing, it should probably not be a scale, it should be dimensions. Dimensions in world units, and position is also not, it's position in world units. Let's look at the shader. Position and scale. Yeah, probably not that. So dimensions, right? Well, let's change this to dimensions. Okay, how would this work? That's the vertices. Well, the dimensions of this rectangle is, so we essentially do need to work out what the scale is, right? Float scale is something, and then we just multiply by that. And scale is presumably just the dimensions. Well, if these dimensions were 1, then scale would be the dimensions, but as it stands, it's more like input dim times 0.5. So, like, if the dimensions are... Wait, hold on. I mean, that's dimensions. We need the conversion, right? We need the conversion. between whatever world units we're using and pixel art. Well, that actually involved. Alright. So we need to somehow convert from our units to these units, and I guess, hold on, let's take it back. Let's take it back to this. Well, we're gonna need to know where the camera is to be able to transform things. So right now, it's as if the camera is just looking at 0, 0, and it's like field of view in each direction is 1. So let's well, I suppose let's move. Well, we're gonna have to store that information in here somewhere. That's gonna be easiest probably. C buffer. Is it like B0 or something? Well, at the very least, we want to know what the camera position is. To be able to move stuff around. But we also want to know what like the field of view is, except this is a 2D game, so really the field of view is just it's more like a camera span or something, you know. Camera half span, I guess. Like we see this many units to the right, this many units to the left, this many units up, this many units down. So we pass that in, and actually for now, let's just hard code them and see how that goes. Let's say the position is 0, 0, and half span is 1, 1. Well then, first we need to move the vertices such that the camera, well, alright, so this vertex is just that. Well, I mean, this is our starting point, right? Is this. Yeah, well, this is just a reference rectangle. Hold on. This is just a reference rectangle. And that's the position of the actual vertex. Okay. No, that's not the position of the vertex, that's the position of the rectangle. That's right. Which I suppose, well, I mean, it doesn't really make sense. Does it really make sense to pass the camera then? I mean, I guess it kind of does. The way I'm doing it here. Yeah, let's just do it this way. like the rectangles, yeah, if that is world space position, then we're gonna have to transform here. Do we have vertex anywhere else? No. Except, yeah, this kind of is the... We're starting off with this reference position, which is just this rectangle, right? And I mean, I guess what I had before, that does kind of work. You multiply by scale, and then you divide by, multiply by scale, and add input position. That does kind of work. And then we can do the other transformations after that. Can we? So let's scale. Well, if the camera span is... If the camera span is 2, and the span of this rectangle is also 2, then that means that the scale is 1. So there is no transformation necessary. Of course, we're passing the scale as the input there. Which is sort of telling us... Hello, chatter. Which is sort of telling us how... Too many things going on at once here. Hold on. Just change this back to input scale. Okay, so nothing's different. Nothing's different. Yeah. Actually, to remain true to the game, let's not bind A and D. Let's bind VK. Is it left? Right? Not left. And VK right. Yeah. Now what are we gonna do about this shader? What time is it? 10:30. Okay, I have some time. I have some time to figure this out. Well, the main thing is to be able to convert between the units. So let's say the camera is just fixed in there, and something is fixed at 0, 0, 0, and something's located at like 5, 5. Should it be visible or not? Like, how do you convert? Well, that depends on how much the camera is seeing. If the camera is seeing 10 units each way, and something is at 5, 5, then it is visible. If it's seeing 1 unit each way, then it's not visible. So essentially this camera half span is telling us, okay, so it's telling us that, right? Given that this is a world space position, yeah, but we also have the edit issue, is that we're trying to take a reference rectangle and kind of morph it into the target rectangle. Which means that oh my god, there's multiple transforms in there. let's see, is it gonna help if I just draw this out real quick? Let's go to Excalidraw. Can they move around? H? Yeah. Break? No. Alright. Alright. The magic of defining and managing your own structs. Well, how do you program without doing that? Okay, how do you use this thing? You do not miss working with C in production. So again, how do you program without managing your own structs? Sloppiness. Oh, anyway. Stroke style. Interesting. Stroke width. Fill. Background. Colors. Shades. Stroke. Structs in C are managed entirely differently than objects in what you'd call a more modern OOP language. I see. Ah, there it is. There's the roundedness. So where's the labor in defining a C struct? Isn't it just multiple values next to each other? Ah, so the labor is in managing, I see. Let's get some numbers in. Can we make it small? I want smaller than that. In manage, one that manages database connection. Well, at that point, it's not really struct management, it's you're writing a whole system. Also GDB. Okay, so that's 0, 0. Okay, what is this? Let's say this is 5. What's text? T? It's a lot less fun when you're managing a massive code base that builds to one binary. Well, would the code base be any better if it was using a modern OOP language? Two, 5, 5. Okay. In this specific case, massively so. I see. 2, 5. Okay, so if we pass in 2, 2 and some kind of dimensions, so 2, 5. Alright, so what do we do here to transform the rectangle? Well, transforming the center, what am I saying? We have a position and we have a scale, and somehow we need to get, so this is world units, right? And somehow we need to transform that into negative 1 to 1, whatever. This is 5 and this is 2, and this should become some kind of 2 and 5, right? 0.4. Yeah, so this essentially just becomes 0.4. And that becomes, 0.4 plus the dimension. Which again, I see. Okay, so the position, whatever the position is in world units, if we just divide that by the half dimension, we'll get the position in clip space. Position in clip is input position divided by camera half square. Well, it's assuming that camera is at 0, 0, which is what I'm doing. Position in clip space. Okay, so this isn't going to change anything. So, but if you make the camera look wider, then presumably that should squish those. Together? Yeah. Is English your native language? No. Russian is. Now the dimensions. You've been learning Russian last year? How has it been? How has it been? It's gotten very tough. Yeah, I did not enjoy learning Russian in school. Nobody does, really. Unless you somehow are naturally good at following strange, esoteric rules about where to put a comma and where to not put a comma. Russian verb tensing. Aren't there 3 tenses? Yeah, English is fantastic. Well, I am from Russia, but I've been living in Australia past 10 years. Dimensions. Dimensions. The scale. Came to the States with no English at all, Georgian immigrant. I see. What did he learn? English clicked when he started thinking in it. Yeah, it does help. Position and clip. Well, I suppose there is such a thing as Georgian. What a nightmare of a written language. Do they have their own writing system? Scale. Clip is something. Well, it's not really scale, right? It's dimensions. They do. Dimensions in clip space would be, let's go back to that. So if this is like 1, the Greek they teach is formal. As in formal but not spoken. Like this, people don't speak it. Almost entirely different from what I've grown up, I see. This is 1. Again, you just divide that. Input dimensions divided by well, Cantonese and Mandarin, and I mean, aren't they just different? Like the writing system is kind of the same, almost, not really, but the languages, like in terms of how people speak, just completely different. Camera half span. So that's the dimensions. Okay, that's the dimensions in clip space. Now we need to work out what the scale is. So if the dimensions in clip space, formal and formal Greek, farm Greek, the people's Greek. So if this is, okay, if we're in clip space and we have some dimensions of like, let's say 0.1, that means the scale is that you need to multiply by 0.1 great-grandmother spoke Albanian. Okay, so if the dimensions in clip space are 0.1, what's the scale? Well, the scale would be 0.1 if but instead it's actually you need to shrink it from 2 to 0.1. So multiply by 0.05. Yeah. So take the dimensions and multiply. Take the dimension. And multiply by 0.5. And let's just rename this to dimensions. Dim works. And redefine the struct, whatever it is here. Dim. Dim. I'll be back to hang for a bit before work. Well, I won't be on for much longer. I don't have a lot of time today. Yeah, it's a much cooler word for it. Well, you know, are you aware of the alternative meaning of that word? Testicles like French and Spanish, yeah. Oh, look at that. Tiny. Brighton Beach. A lot of Spanish and French going on in Brighton Beach. I don't know what Brighton Beach is. Okay, these are the dimensions. Okay, so I'm saying that the camera is seeing 10 units each way. Set this up. Brighton Beach was where most of Russians and Ukrainians settled in the 30s and 40s. Okay, so we've got Big Egg. Well, okay. What's going on here? We've got nice talking to you. Yep. Take care. So these are the dimensions. So we're looking at world space, and we're looking 10 units each way, which means that if we move this 5 units to the right, and let's say 8 units down, the second rectangle should end up in the lower right quadrant. That seems right. Now the units, so if we're looking 10 units each way, if the dimension's at 10, then it should occupy half the screen. Which is about what I'm seeing here, yeah. Okay, so the transform seems to be working. Of course, camera position is the next thing. Okay, well, camera position. Well, I mean, that's pretty simple, right? We just do position in camera. Position, camera space, camera position. Position camera is input position plus, well, maybe I guess minus. Because if the input is at 5 and the camera is at 10, then the input is actually at -5. So minus camera. Okay, this shouldn't change anything. Oh, by the way, what happens, like, let's make sure that unequal dimensions are correctly displayed. They are. They are. Now let's move the camera to like where is this thing? 0, 0 in world space. Yeah, and if the camera is moved 3 units to the right, then this big rectangle should move to the left, presumably. It didn't move to the left, because I'm not using posing camera. Now it moved to the left, okay. And if we move the camera up a little, then the big rectangle should go down. It did go down, okay. So let's say we have this other rectangle, which is going to be shorter, and it's going to be on the same x-plane, and it's going to be to the right. Say 4 units to the right. That way. That's 4 units up. Yeah, so now it's 4 units to the right. Of course, we're referring to the center. So it shrank, like, appropriately. Okay, so the next thing would be to actually pass this in into the shader. And then move it around, although, I mean, in this game, I guess the camera is always centered. at where the player is. Except for when you go to the edge of the world, in which case it kind of gets, it stops. The camera stops, but the player can keep going. So they are separate. Okay, so anyway, so that's for next time. Toggle focus. Focus into primary, yeah. Yeah, or oh my god. Well, oops. Okay, seems fine to me. Use mapped buffer as persistent storage. I guess that's what I did. Alright, and that's all for today. Thanks everyone.